Hello students, welcome to our video lecture series. Today we are going to discuss about principle of drawing. First of all, we should know what is the drawing. So let us see its definition. What is the drawing? Drying is an important unit operation in which we can remove the moisture from agricultural product to its predetermined label. So one thing here in the definition, one word used which is unit operation. So what is the unit operation? Firstly, we should know what is the unit operation. So in our post-harvest processing, unit operation is important operation like cleaning, grading, sorting, packaging, even transportation is an unit operation in our post-harvest processing and drying also. So we further talking about what is the need of drying, क्योंकि हम कोई भी सब्जेक्ट पढ़ते हैं तो हमें ये पता होना चाहिए कि why we are talking about, हम क्यों पढ़ रहे हैं इसको. तो what is the need of drying? When we harvest any agricultural commodity to its physiological maturity, they contains a lot of moisture. So it is not safe for storage. So that's why we can dry it for further storage for certain periods or to protect them against fungal, mold, insect and other microorganisms during storage. So when we harvest any agricultural commodity, they contains a lot of moisture present in it. So there is a two forms of moisture present in the grain. First one is unbound moisture. And second is bound moisture. So like this is our grain. So which type of moisture we can say it is unbound, or which type of moisture we can say it is bound? So we can divide the grain into two parts. This is inner part and this is outer part. And outer part contains a lot of moisture. This is called unbound moisture. Unbound moisture like act as a free water surface. When we put in open pan of water, so water acts as a free water. So the unbound moisture is act as a free water surface. Like when we put water in an open pan, so act as a unbound moisture. That is called free water surface and that is called unbound moisture. The same phenomena works here. Then again हम बात करते हैं when we talking about bound moisture. Bound moisture is present inner part of the grain. It is called bound moisture. Bound moisture is with the absorbing material of the grain. Mutual reaction takes place between absorbing material and water molecule. Finally, water molecule जिसे हम H2O कहते हैं, ये जो है chemical constituents of grain. Finally, water molecule is in bonded with chemically bounded with chemical constituents of the grain like carbohydrate, protein, vitamins. तो इनके मॉलिक्यूल्स के साथ में ये जो ग्रेन है, वाटर मॉलिक्यूल है, ये बॉन्डिंग फॉर्म में इसमें प्रेजेंट रहता है. So we can say that this type of moisture we cannot easily remove or evaporate from the grain during drying operations. So for better understanding, one thing is here which we should know by the graph. Basically, in our farms or any agriculture commodity, we can classify into three forms. First one is perishable product. Second one is semi-perishable product. And third one is non-perishable product. Perishable product means they contains or they deteriorate fast because it contains a lot of unbound moisture like vegetables and other high moisture content agriculture commodity, fruits हो गया. तो when we go through or when we dry this type of product, the constant rate drying is longer in this type of product. When we going to dry this type of product, the material undergoes firstly constant rate drying, and constant rate drying this type of product is very long. So हम यहाँ ग्राफ से समझते हैं. This is drying rate and its moisture content. It is x-axis and it is y-axis. When we go through drying or when we dry any agriculture commodity like perishable, firstly we can say we are talking about perishable product. When we go perishable product to dry, the constant rate drying, it follow constant rate drying, and constant rate drying period is larger as comparison to semi-perishable food, because the unbound moisture present in it is a greater amount, and then it follow first falling rate period, that is called F1, and it is C, and then it follows second falling rate period, that is called F2. We are talking about perishable food. Again, we are talking about semi-perishable food. They contains less amount of unbound moisture as comparison to perishable product. So the drying rate curve is shorter as comparison to perishable product. This is A, this is B, and first falling rate period and again second falling rate period. Its first falling rate period, the non-perishable food, semi-perishable food attains earlier or in a shorter period. Then we are talking about non-perishable food. Non-perishable food, there is no any amount of unbound moisture or very less, so it undergoes directly first falling rate period and then second falling rate period, F1 and F2. Most of the agriculture commodity or any grain follow this drying curve or this drying phenomenon. Again, removal of moisture from wet material by vaporization depends on the rate of heat and mass transfer, which is related to the following two basic phenomena. First one is vaporization of moisture from its surface. The two basic phenomena works here. Vaporization of moisture from its surface, like this is grain. When we go through drying, so first one is vaporization of moisture from its surface, and second movement of moisture from interior part of the grain to its surface. Okay, so first one and second one, movement. First one is vaporization of moisture from surface of the grain, and second one is movement of moisture from from interior of the grain to its surface. So basically drying theory revolves around one thing, which is called vapor water vapor pressure. Water vapor pressure. So movement of moisture takes place because of diffusion, cell contraction and water vapor pressure, and it is the most important thing which is water vapor pressure. That it is the drying chamber. And when we put grain to dry, it is grain. What phenomena works here when we go through dryer or when we dry an agriculture commodity? There is a water vapor pressure inside the grain, and there is a water vapor pressure of drying chamber its own, which we can set. So when a simple principle works here, moisture movement always higher vapor pressure to lower vapor pressure. If we lowering or if we increasing the water vapor pressure inside the grain as comparison to drying chamber, water will move from higher vapor pressure to lower vapor pressure. It is higher vapor pressure. And its vice versa also applicable here. When we dry an agriculture commodity or grain and put it in open atmosphere, so what phenomena works here? Grain gain the moisture from atmosphere because of the vapor pressure. Atmospheric vapor pressure is higher than the inside grain water vapor pressure. So grain absorb the moisture and it deteriorate. So which type of dryer or which type of principle we apply for lowering the vapor pressure of drying chamber or higher the grain vapor pressure? So it is one thing is sun or solar drying, the method which we can apply for drying any agriculture commodity through higher the water vapor pressure inside the grain. So we can go through sun or solar drying. Number second, convection time. Number third, क्या जाएगा? इंफ्रारेड ड्राइंग. And second basic principle, if we lower the water vapor pressure inside the grain, so what principle we apply or what method we apply? Desiccated air drying. First one is desiccated air drying, heated air drying, and थर्ड वन इज क्या बोल सकते हैं इसको, हीटेड एयर ड्राइंग। उसके बाद रेफ्रिजरेटेड एयर ड्राइंग। So I think it is enough. Again we will meet you further video lecture. So thank you students.